Hey everybody, welcome back to Faraday Research. It's Sunday night and it's about 9 o'clock, and I've been toying with some other ideas and got some more parts in. And what I'm going to be doing is explaining what I did with this car relay. And I did something very special with this, which I'm going to share with you. Now, this relay I tied into the pulse motor, and I got some very interesting results. So first, I guess we'll get into this relay. So what it is, it's a car auto relay. Now this one here is a 5-pin, not a 4-pin. Most of the ones that you see out there are 4-pin. This one's a 5-pin. So what this allows me to do, when you hook it up in a certain manner, you can turn this into an oscillating relay circuit. So, I found the plans online. They're really easy to do. I hooked up all the wiring, connected it, and I hooked it up to this 8-watt bulb. So what I'm going to do is I'll turn it on, and then you'll hear it. It's going to start buzzing. So what's happening is the middle pin that's on this, that's the 5th pin. If you short that out between the one that controls the switch, what happens is it shorts it out and causes that, it's basically called normally open, I believe it's called, normally open on the relay. So what it does is it starts oscillating at a very, very high rate, so it goes into like a buzzing sound. It's kind of irritating, but it works. So I have my voltmeter set to 12 volts, and I'm going to turn it on, and then you can see that the light's going to come on. Okay, so you hear that sound? That's coming from this. So it's buzzing away. It's got a coil inside, and the coil's collapsing, going into resonance and causing the light to come on. So I've turned 12 volts DC at, it's drawing very little amperage, 0.01, so 10 milliamps, and it's able to light up an 8-watt bulb. LED bulb, this rated at 8.5 watts. Pretty impressive for an automotive relay. So that's pretty cool. All right, so we're gonna get into the next part here, which I found kind of really cool. If you haven't subscribed to the channel, you can do so bottom right hand corner. If you like the video, give me a thumbs up. All the descriptions, links to my donate, to my Patreon. I'm gonna be putting the circuit diagram for this relay in my Patreon. So if you're a Patreon, you'll be able to see the diagram how to hook this up. So getting back to what I plan to do here, I'm just gonna put the phone down here just for a second because I have to change some wiring. Sorry about the view. So what I'm gonna do is now I'm gonna hook up this oscillating relay. I'm going to hook it up to the pulse motor now, and I got some interesting effects. So I'm going to hook it up. Now when I hook up the oscillator to the pulse motor, it does draw a little bit more power, but that's okay. But I'm going to explain where this thing actually enhances everything. So now I got it hooked up to the pulse motor. It's on the out. All right, so this is now hooked in to the pulse motor. Now I also still have the piezo transducers hooked up, the 3 of them. Okay, so this is very important. So what I've got out of this experiment is I got this coil running this switching device. Okay, now these piezos now get this coil in resonance, which increases the output, and I can tell just by the sound coming off the relay, that thus giving me more output. Okay, now I've got this thing hooked up into the equation. So I'm going to show you first without the piezos, and you're going to notice that the light is going to be on, but it's not going to be solid. It's going to be flickering. All right, so I'll get that going here. All right, let's get her going. Okay, so you can hear it. All right, you can hear it running. So I got it going, so you can see the flicker. Okay, so I've got this coil here is not in resonance. So what I have to do is I gotta get this in resonance with my piezo's, the piezo's in resonance with my switching device, and this will go even more solid and more consistent just by hooking up the one lead. Because right now you can tell it's flickering. Well, I can see the flicker. Yeah, you can. All right, so I'm going to hook it up. Now watch what happens. Okay, now the piezo's are hooked up. Okay, that flicker is now totally gone. It is solid. It might actually look flickering on your screen, but for me, it's a lot brighter, for one. A lot brighter. A lot brighter if I hook this light just directly to the pulse motor. I can't get it this bright. If I take the piezos off, it goes dimmer. The second I hook the piezos back up, now all the coils from here, there, and the main coil of the motor are now all in resonance together. And now I got a really bright light, just to kind of show you how bright it is. There we go. You can see how bright it is. So a dramatic change in power output. Dramatic change. So it still seems like the piezo transducers are adding to this equation to get everything into resonance, because it's actually in the middle of my circuit. I got coil, piezos, another oscillator. So now all three of them, everything is now in resonance. And as a result, I got a lot more power output. Now, if we go to my voltmeter, I haven't changed anything. So just running the buzzard, the relay buzzard on its own, only takes 10 milliamps to run it at 12.4 volts. So now with the pulse motor in, it's using 140 volt milliamps. Okay, it's a little higher, but still for a pulse motor, 140 milliamps is nothing. Is nothing. Now this light is bright, very bright. That means I'm getting a full 8.5 watts. And here, somebody will have to work it out on a calculator. 12.4 volts times that by 0.14, and that'll give you the output watts. Offhand, I don't know what it is. I think it's hovering around 2 watts, 3 watts. And I'm running 8, solid 8 watts. So you need to have a coil on the end where your power out is, and then the piezos in the middle to get everything in resonance. Because you'll see the difference the second I disconnect those piezos. Watch. Now I got flickering. It's not in resonance anymore. As soon as I get it into resonance, it gets a lot brighter than what it is now. It actually dimmed quite a bit. You can't really notice it too much on camera, but I can. It dimmed quite a bit. Second I get the piezos, way brighter and solid. So I know I'm getting a solid 8.5 watts. And I'm putting out, 2 watts? Putting like 2 watts into the system, or whatever it is. Yeah, somebody will have to work it out. 12.4 volts at 0.13 or 0.14 amps. That'll give you the watts. So I'm making a huge gain from how much I'm putting in to how much I'm putting out. So now I'll have to work later in the week and try to loop it into caps and just have the cap bank running the whole show. If I can sustain that cap bank, this thing will run forever. So just with adding this new oscillator, and you can hear it, it's not too loud now. Surprisingly enough, it's not that loud. When it runs on its own, it starts buzzing a lot louder. I don't know. It's weird because I'm putting more power into the system, but yet if I run this oscillator on its own, it only draws 10 milliamps, which is nothing. And it can light this bulb up. Not all the way, about halfway. So it's about 4.5 watts on its own. So yeah, tell me what you think, everybody. Leave your questions, comments below. I'm going to be doing another video this evening on my Don Smith generator. I'm going to be hooking up not just the one coil I made. I'm going to hook up both of them together, and I'm going to see what kind of a difference in power output I'm going to have. So that should be interesting all in its own. So, anyways, yeah, give me a thumbs up, and we'll see everybody soon.